A brief review of Module 1. If you happen to have your workbook still, Volume 1 on page 52 was a summary of Module 1. If you still happen to have your book. So these were the main topics in Module 1. We learned some of our basic vocabulary, points, lines, planes, and then how to represent segments and lines to tell the difference between. Remember, a point is essentially non-dimensional, and we represent a point with just a capital letter. A line is two-dimensional, and we represent the line two ways. We could name it with 2 points on the line, or sometimes a line may just have a lowercase cursive letter next to it. So we would just call this line D. And of course, you guys know that if you put that double arrowheads over the top of the M and the N, that's how we would name that line. Those are the two options. The plane is three-dimensional, and the plane generally has a fancy cursive uppercase letter, so we could call that plane M. You also can name a plane with 3 points in the plane as long as, if I call them X, Y, and Z, as long as those points are not on the same line. So we could refer to that as plane X, Y, Z or plane M. Then we moved on to formulas, midpoint, distance, and then we looked at partitioning segments. So the midpoint formula, of course, is going to give you a point. So when you're locating the midpoint, you're locating the point that splits that original segment up into two equal pieces, a 1-to-1 ratio, if you will, so that those are congruent. If this is, you can think of it on a number line, or you can think of it in the coordinate plane. Let's just go with the coordinate plane. So if these are two ordered pairs in the coordinate plane and you want to find the location of the midpoint, you simply average each of the coordinates. So you're going to average the x's and average the y's, and that's how you find the midpoint. If you want to find the distance between 2 points on the coordinate plane, and it's not a horizontal segment, so perhaps they're leaning. If it's horizontal, you can just count. These should both be. So x sub 1, y sub 1, the order doesn't really matter. If you want to find the distance between 2 points, what we've come to do is really just create our right triangle and do the Pythagorean theorem, which is probably the way you want to do it. But there is a formula for distance. So if you wanted to find the length of that segment D, the distance formula is, it's a big square root, and it's just going to be the difference in the x coordinate squared, the difference in the y coordinate squared. Add that together, take the square root of all of that. You're really just doing the Pythagorean theorem when you do that. In terms of partitioning segments, there were 2 ways that we learned to do it, given a ratio or given weighted averages. So if you have a ratio, so we want to locate a point on this particular, this is a number line. If we were doing it on the coordinate plane, we would just add this same thing again for the y coordinates. But if you want to find a point between 2 others so that it splits them up into an m to n ratio, this is the formula that you use. So n gets multiplied by the first value and m is multiplied by the second in the ratio, and then you just add those 2 quantities together. And then in terms, let's just do a quick example of that, and we'll just do it on a number line. So let's say we have the number 4, we have the number 10, and I want to find point C so that C splits them up into a 1-to-3 ratio. That would mean there would be 1 part between 4 and C and 3 parts between 10 and C, 1-to-3. So you're going to multiply 4 times 3, the 1 times the 10, and add the 2 numbers of your ratio together. So we've got 12 plus 10, that's going to be 22 over 4, which is 5 1/2. So that point would be located here at 5.5, which visually makes sense, right? One part between 4 and 5.5, and then we would have 3 equal chunks between 5.5 and 10. The same thing with the weighted averages. So these are the ones where it might say B is 3 times X, and Y is 2 times X, the weight of X. Find the weighted average of those points, the point that represents that weighted average. So B would be multiplied times 3. Everything was being compared to X, so remember that meant that X had a weight of 1, and Y would be multiplied times 2. So whatever B was, you would multiply it times 3. Whatever X was times 1, and Y would be multiplied times 2, and then you take the sum of all the weights. 3, 1, and 2. 3 plus 1 plus 2 in order to determine that weighted average. So I'm not teaching it for the first time, you've seen it before. However, that is in a very brief nutshell everything we did in Module